Let us perform a hypothesis testing about a proportion. So a researcher claims that based on the information obtained from the Centers for Disease Control and Prevention, 17% of the young people aged 2 to 19 are obese. To test this claim, she randomly selects 200 people aged 2 to 19 and found that 42 were obese. At 5% significance level, is there enough evidence to reject the claim? Let's start with the null hypothesis. Insert. That's not. P is equal to 0.17. Now that's the null hypothesis. And let's see what is the alternate hypothesis. It is not equal to 0.17. And what is the claim? Researcher claims that 17% of people are clean. Now the researchers collected the data. We don't know the proportion estimate that we're going to get from the sample directly, so we will have to compute it. We know that sample of 200 people were taken, out of which X number of people were obese, 42. So what is P hat? The best estimate of the proportion. So P hat is equal to 42 out of 200. So the proportion observed in the sample is 21%. The proportion claimed is 17%. We want to check, is this 21% statistically different from 17% or not. We'll check for the precondition. We want the sample to be random and each one of them are independently drawn, so that's mentioned here. We need to check the NP and NQ conditions. So NP, NQ, the P is 0.17 and Q is of course 1 minus P is equal to N times 0.17 and Q will be N times 1 minus P. So both of them are greater than or equal to 5. So we can apply the z-test for proportion here. We need to test it at alpha is equal to 0.015. So alpha point 0.05. So it's a two-tailed test. So we will compute alpha by 2. Insert two alpha. Alright, so what is alpha by 2? Alpha by 2 will be alpha divided by 2. Now we are going to determine the critical Z star, the critical value, which will be corresponding to 97.5%, leaving 0.025 in the right tail and 0.025 in the left tail, is equal to norm dot this standard inverse 1 minus 0.025. We can compute it for the left hand tail also, which will just be negative. For the sake of verification, I can just show you those values. Equal to norm this inverse at 0.025. So that's the value at this, and that value will be minus 1.96. Okay, so now let's compute the statistic. We know P is 0.17. We need to know P hat. Okay, let me write down the formula for the Z value. Insert P Z equal to minus P divided by the standard error, which is square root of PQ by N. N PQ. Right, so we are going to use it to compute the Z. We have P hat, N is 200. So what will be, we can compute this denominator as SE, standard error, is equal to square root of P times 1 minus P, that is Q, divided by N. Enter. Let's check what went wrong. Oh, 1 minus P. 1 minus P. So that's 0.0265 or 267, whichever way. So what will be Z? Z will be P hat minus P divided by standard error. 1.506 is Z greater than Z star. Z greater than Z star. False. We observe that Z equal to 1.506 corresponding to P is equal to 0.21 is less than the interval limit of p is equal to 0.17 at 1.96, right? That's what we observe. So what is the inference? We do not have enough evidence to reject p is equal to 0.17. In other words, the observed p is equal to 0.21 is not statistically different from p is equal to 0.17.